Section 2 deals with wave properties, and what we're going to be looking at with the wave properties is mechanical waves. Now, mechanical waves requires a medium to travel through. Now that medium, right now I have a mechanical wave traveling right now, my voice. It's traveling through air, so you can hear it, but a medium can be air, water, even the ground. And with mechanical waves, we have two different types. One of them is a transverse wave, wave that vibrates perpendicular to the direction of the wave's motion. Now, one of the things with these, we could possibly have what's called a wave pulse, which is just a single bump or disturbance that travels through the medium. And if the wave travels up and down at the same rate, this is a periodic wave. Or we can have what's called a longitudinal wave. And this is a wave that vibrates parallel to the direction of the wave's motion. Now, if we're going to be talking about waves, let's kind of look at the anatomy of a wave. So we have wave right here. So let's kind of label it down. So the top part of the wave, this is called the crest. Bottom part of the wave, this is called the trough. The height of the wave, or how big it is, this is called the amplitude. And the distance that we can have between either two crests or two troughs, this is called the wavelength. Okay. Now, one of the things, wavelength is represented with this Greek symbol. Looks like an upside down Y, and that is called lambda. Now, some other things that we can have with wave, we can have the frequency, which is just the number of complete oscillations a wave makes each second. And the way that we can calculate out the frequency is we can take F, which represents frequency, we take 1 over the period, or the time it takes for the oscillations to go through. Now, as I said, wavelength is represented with lambda, distance between two crests or troughs. And the way that we can calculate out lambda is we can take our velocity over our frequency. With frequency, the units that we can use, or we'll see, the SI unit is hertz, which is represented Hz. Now, since frequency is of each second, hertz is just equal to per second, s to the negative 1. So let's kind of look at an example of information from Section 2. Section 2 is really, really short, so this video is going to be short for you today. Sound wave has a frequency of 192 hertz and travels the length of a football field, 91.4 meters, in 0.271 seconds. So we're going to calculate all this stuff out. So A, what is the speed of the wave? B, what is the length of the wave? C, what is the period of the wave? And D, if the frequency was changed to 442 hertz, what would the new wavelength, what would be the new length and period? So let's kind of work our way through this. So speed of the wave. Well, speed or velocity is distance over time. So our distance is 91.4 meters. That's from the information given to us. Time, 0.271 seconds. So if we take 91.4 divided by 2.271, our speed or our velocity is 337 meters per second. Okay, B, what is the length of the wave? So we're going to be looking for wavelength. Velocity over frequency. So if we find our frequency first, 1 over the time, so 1 over 0.271 seconds. Trying to look for things on here. Coming up with a frequency of 3.69 hertz. Oh wait, excuse me, sorry. I completely forgot that it gave us our frequency as 192 hertz. Sorry about that. But we don't even need to look for that. So we take our speed over our frequency. And seconds are going to get canceled out since hertz means per second. Okay, so 337 divided by 192. Coming up with 1.76 meters. C was the period of the wave. Okay, so period would be 1 over F, so 1 over 192 hertz. So I'm coming up with a period of 0.0052 seconds. Okay, now D. If the frequency was changed to 442 hertz, what would the new wavelength and the period be? Alright, so for the new wavelength, we're still going with the same velocity, 337 meters per second, over our new frequency, which is 442 hertz. And seconds and hertz will get canceled out, so 337 divided by 442. So I'm coming up with 0.762 meters, and the new period went over 442 hertz. And coming up with 0.00226 seconds. Okay, so this should help you with some of the problems on the assignment that I sent out yesterday. If you have any questions, let me know, and I will talk to you later. Thank you.